Welcome back to Advent of Code 2024, day 13. Welcome in, DIJ. Wait, when did Twitch change it so the stream info is now on top of the window? Dunno, haven't seen it myself. I'll check later. Alright, so... let's just start this. One second. So the connection's unstable. I should have... oh, I'm on the wrong network. Hang on. 1 second. If I don't know if this is going to cut the stream. I just need to... Alright. Hang on, I'm just waiting to Are we back? Okay, we're back. I had to switch to a different network. I was on the wrong network. It was really spotty. Alright, hopefully this works. Alright, so yeah, we're on day 13. Before I... oh, just need to do one more check. Sorry. Oh, might as well get my coffee. Alright, let's open the problem. 13. Lucky number 13. It is a lucky Friday the 13th. Claw contraption. Alright, next up, the lobby of a resort on a tropical island. This was from 2020. Okay. The historians take a moment to admire the hexagonal floor tiles before spreading out. Fortunately, it looks like the resort has a new arcade. This is what an arcade is, for those who are too young to remember. To be fair, I don't think I ever went to an arcade because I wasn't really in the countries that have them when I was a kid. Maybe you can win some prizes from the claw machines, and these are claw machines. Certainly they're still very popular in Japan and South Korea and Taiwan as well. The claw machines here are a little unusual. Instead of a joystick or directional buttons to control the claw, These machines have two buttons labeled A and B. Worse, you can't just put in a token and play. It costs 3 tokens. What a ripoff. To push the A button and 1 token to push the B button. Interesting. It's just A and B. Alright, with a little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis and a specific amount forward along the y-axis each time that button is pressed. So each button does a vector, basically. Each machine contains 1 prize. To win the prize, the claw must be positioned exactly above the prize on both the x and y axes. Okay. So we have to reach a given destination via these 2 vectors. So really it comes down to finding 2 integers. So if we have x, let's say if we have A presses of the A button and B presses of the B button, it should be something like, I'm running out of variable names, just like lambda A plus gamma B equals that destination. So we're really trying to find that vector, lambda gamma. Let's read on. That might not be what we're trying to do. Each machine contains 1 prize. To win the prize, yeah, okay. You wonder what is the smallest number of tokens you would have to spend. So we're trying to, in the example I gave, we're trying to minimize lambda plus gamma. Okay, what is the smallest number of tokens you would have to spend to win as many prizes as possible? You assemble a list of every machine's button behavior and prize location. Pushing the button's A button will move the claw 94, 34. So we can't really use linear algebra here because you have to press an integer number of times. So this is an integer programming problem, essentially. The claw machine sounds like more of a rip-off than a normal one. Depends how much the prize is worth. It could benefit the mathematicians that can work out the optimal press, maybe. Shouldn't it be prizes are located at 8? Okay, fine. So A. Sure, okay. For the second and fourth claw machines, there is no combination that would ever win a prize. We're trying to minimize the sum of those 2. You estimate that each button would need to be pressed no more than 100 times to win a prize. Okay, that's a very useful condition. That means we don't have to find a proof that it never meets the objective function. We know that if it doesn't meet within 100, if we can't find it within 100, then we're done. Figure out how to win as many prizes as possible. What is the fewest tokens you would have to spend to win all possible prizes? So this is like a problem you could just plug into NumPy and it would just give you the answer. This is a linear programming problem, but it's in such few dimensions that we can just do it exhaustively, I'm pretty sure. So alright, seems easy enough. This is GCSE algebra. I mean, you would have this problem on a GCSE mathematics exam paper, but you'd have to do it with a calculator instead of a program. All right, so we just have to make sure we're parsing this correctly because we got it like this. So all right. All right, well, okay. So we want, okay, let me turn the AC off. The AC is a bit loud as well. All right, I wouldn't normally use regular expressions, but here it might actually be worth using them. So let's see. It opened. So we open the file, and we want to read. Basically groups of like 4 lines at a time. So we'll just say, oops, all right, so we want to say if I% for, so if it's a multiple of 4, that means we're on the button A line. So pattern equals, it's basically going to be that, but this will be digits, more than 1 digit. That is the pattern. Now I don't remember how to use regular expressions. What do we do with that? We want to capture... I've got to remind myself how to do this. Python regular expressions. But this is not actually going to save me time over. But it's good practice. Python regex capture groups. A group is a part of a regex pattern enclosed in parentheses. So we should just be able to... Yeah, as I suspected, we just do this. Why is the computer running really slowly? Is PyCharm indexing again? I hate it when it does that. I'm not sure. So that's the pattern. Resulting. So we want line dot search or match. What's the difference? Line dot match. The pattern. No. What? No. RE dot match pattern to the line. Let me just print. Is that just going to be the two ints? None, 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 none. Okay. Wait, are these pluses also need to be escaped? Oh, there we go. So pluses are special characters. Of course, because I just used one there. The joy of regex, yeah. I would have been done by now if I just did it the hacky way. Alright, so... Then what? re.match dot groups. Okay, there we go. So we'll say AX AY equals int Z for Z in re.match groups. All right, make sure this is working. Okay, good. Wait, is it right? 1257, 1257. The next one should be 1746. Okay. Otherwise, if it's 1, we want button, it's just going to be button B. Yeah. But this is going to be BXBY. Otherwise, if it's 2, pattern is prize. Capital X is fine. Yeah. Okay. So this is gonna be like that. And we'll call this PXPY. And if it's 3, we'll just skip the line. So the moment we've got the prize, we can then push it all to we should actually reuse the pos class that I've been using, this one. So we want add. We don't need subtract, but we can take all of this. Alright, we don't need subtract. Do we even need this? We'll leave it in for now. Okay, so the moment we've got the prize, we can compute the solution. What is it they want us to do? Find the minimum number of tokens. So we're going to find the minimum. Okay. So let's call this to find get min tokens. So given the vector for button A, the vector for button B, it's called be more descriptive than that. A button, B button, prize, A vector, B vector, prize vector. So for a given A, B, and prize, we want to basically just do the brute force approach, just say try from 0 to 100. So let's say the best we found, best tokens best coefs, let's just call them coefs, equals, let's say, none. So the idea is okay, so we go for, should do I and J. Yeah, I in range 100. 101. We actually do want to include 100 itself. And we do want to start from 0. No more than 100 times, yeah. Okay, so for J in range 101. If so we do I times, oh, we didn't a scalar. So we want define. We don't want to multiply two posits together. Just say define what's the best way to do this? Okay, just scalar mul. This should really okay, it's fine. Return pos a times I, a times j. Oh, self.i, self.j. There we go. So if we want, so we take the a vector, scalar mul by I, plus b vector dot scalar mul by j if it equals price vector, that's a match. Then we say if I plus j is strictly less than the best. So, okay, no. If best tokens is none, or I plus j is strictly less than the best tokens we found so far, then we found a better pair. So we have to say best tokens equals I plus j, best coefs equals well, I guess the tuple ij, and ultimately return best curves, which might be none. All right, so here, so what do we do when it's none? What is the fewest tokens you would have to spend to win all possible prizes? So we ignore the ones that are impossible. Okay, fine. So min tokens equals 0. And here we do tokens equals get min tokens. So we've got pos AXAY, pos BXBY, pos PXPY. If tokens is not none, we don't need both of these. We just care about the sum of the two. Min tokens plus equal tokens. Okay. 19596. Nope, it's too low. Okay. Fewest, no, see, just read this again. Fewest tokens you would have to spend to win all possible prizes. Alright, let's try this example. Hang on. Let me look these over again, these regexes. Yeah. Take that out. Right then, let's try the example. No. Two, 4, 4. Should be 480. Okay, that's way off. Oh my god, I forgot one more thing. That weird thing they introduced at the beginning. It costs 3 tokens to push A and 1 token to push B. So it's actually... What is eating all my RAM? Something is slowing down my computer so much. Is Windows updating or something? It's not PyCharm. It's not indexing. Oh dear. Let me just check. Does seem like PyCharm is using an unreasonable amount of memory. Maybe we just shut it down and open it again. That's weird. Okay. Let's just wait for the jet engine to cool down. Anytime now. All right. Okay, I hear it cooling down now. Let's open PyCharm again. Normally there's an indicator if PyCharm's re-indexing, which so I don't think that was happening. I don't know what happened. Scanning files to index. Alright, that's happening. Can you not happen? Alright, well, it seems to have stopped. So I think this should work now. Okay, well, no, we need to change. So it's 3 tokens to press A. So it's going to be 3 or it's going to be 3 times I plus J. $480. All right, that's correct. Let's just get the. So we're doing roughly 10,000 iterations per thing, that's fine. Correct, okay. As you go to win the first prize, you discover that the claw is nowhere near where you expected it would be. Due to a unit conversion error in your measurements, the position of every prize is actually this number higher on both the X and Y axis. Wonderful. Okay. Add that to the X and Y position of every prize. After making this change, the example above would now look like this. And we no longer need 100 presses. Okay, so now we have to be smarter. Okay, so alright, first of all, for a given value of X, it's clear what we should try to set the Y to. You can just use just like integer division to work out roughly what it should be. So, but still, there's a lot of X values. So what else can we do? This is literally this is where you use the simplex algorithm, although that's quite complicated to program. All right, so basically
How big is this number? One. So it's thousands, millions. Okay, we can't even range. We can't even range X over this. That's, yeah, well, that's to be expected. Okay. So I guess what we want to do is say okay, so maybe if I just draw a diagram here, that'll help. So we've got with that paint. Okay, I should have the capture the paint over here. Or not. There we go. So we've got basically lambda times A plus mu times B equals P. We're trying to minimize re lambda plus mu. Trying to minimize that. So if so yeah, linear programming, you would just plug this in and you would get it, except it would be fractional. So if we're doing an integer program, I can't remember what you do. You want to find the fractional solution, and then will the correct integer solution be nearby? Is that usually the case? So if we found lambda and mu to be like fractional numbers, then what do we do? That won't work. Can't remember what you do in these situations. I think we want to mu. Mu. For a given lambda, we can find mu easily. That's easy enough. All right. The real question is, how would we prove that there isn't a solution? I'm back. How goes the regex? Regex wasn't a big factor really. I did the regex for the for capturing the input. That was fine. Now we're doing the same problem, but instead of these being the prizes, we've got basically like a trillion times bigger. The prize is basically a trillion times further away, and now we're trying to find the minimum, as before, the minimum number of A presses and B presses to add up to that trillion. I think it's even bigger. I think it's like a quadrillion. So I think they're getting at some sort of linear algebra here. I can't remember how this works. So we know that this is lambda is how many times you press A, mu is how many times you press B. If we do lambda A plus mu B, we get P. So we're basically trying to minimize this such that this is true. And yeah, these numbers can be very big. If the prize is in the quadrillions or whatever, then that means lambda mu can be of the same magnitude. But what's more is we also want to know if there's simply no solution. Okay, so what do we do? I don't remember what to do. This is integer programming, so we can't quite use Google this. I think there's actually a technique for this. Let me quickly search. Two-dimensional integer programming. Alright, algorithms for integer programming. Yeah, these algorithms don't look easy to program. I remember studying these, but I also remember that the algorithms were not easy to program. Taboo search. Wait, another thing I could do is try using, just use Z3, whatever it's called. Z3 Python. Let me check. Z3 minimize teacher. Alright, I think it does support this. I'm just trying to find a... Z3 for optimization problem. Just trying to find a simple guide. All right, let's just start typing and see what comes up. So let's import Z3. Thought I already installed this before. No module name distutils. Hang on. That was on a previous laptop. How do I... Settings... Oh, not that. Where is the... Okay. Why am I getting errors trying to install anything? Add package. Oh, I don't just... There we go. Z3. Install package. Okay, it's installing. I had to use Z3 once before. For it was like a physics problem involving asteroids or something. Error? What is wrong with this? Could not install packages due to... Alright, I've got to go into the Windows terminal here. Maybe upgrade pip. Oh, it did install. Okay. We've got Z3. Alright. Let's try and use Z3 then. Get min tokens. Alright, we're making an... Let's comment this out. We're making a new one here. So we've got Z3 imports from Z3 import star. Alright, so we want to say AX equals int call it AX, I guess. No, is that what you do? Hang on. Z3 solver in Python for optimization. Okay. Int, real, or bitvec? Sure. Ints. It's called ints. Alright, AX equals ints. Is it not? What? X, Y equals ints. This is what the guide says. X, Y. They changed it? Where is the documentation for this? Python Z3. It's int. No. Yes, it's int. Why didn't int work? Is it supposed to be grey? It's only grey because we haven't used anything from it yet, but I can try and dots. Let's try doing import. I think it should be maybe it should be capital. Oh. Import Z3. Alright, and then do Z3 dot int. I don't think we even have the right Z3 here. What is this? Backup as a snapshots to Z3. Maybe it's not even called Z3. What was it called? Z3. Maybe it should be Z3 Pi. Yeah, I just saw that. I think that might be... No. Well, it depends what's in whatever it's called. Z3 Solver. I think it might be Z3 Solver. There we go. Install that. Okay. From Z3 Solver import star. We're not allowed to do that. Have a hyphen there. Well, what do we call it then? If that's what it was called. Z3 from... Yeah, we can't have a hyphen in a name, so... Is it called Z3 when we... Alright, let's uninstall Z3 because I think that's interfering. No uninstall button. How do I uninstall it? What am I supposed to call it if it has a... So many problems. I think you just call it Z3, but then we've got two Z3s now. Is this gonna work? I think it might work. Okay. I don't like the fact that I've got this thing called Z3 now. Yeah, how do I uninstall this? Delete package, there we go. Okay, just stick with this one. Alright. Import z3.z3.int. What? Okay. Like that. There we go. Alright, so ay equals int ay b. So basically we want this. I don't know what they were expecting us to do. There's some... I don't remember my linear algebra, but there's probably some algorithm I could have written to do this, which may have been quicker than messing with this, but Z3 is a good tool and it's useful, so it's worth trying. This is all wrong. Hang on, we don't want... No. The variables are just lambda and mu. Let's say... Hello, Jessenberries. Alright, so... Where's my mouse gone? Okay. Hang on. Why is it lagging so much? Right. Let's just say L and M. L equals int L m equals int m. Okay. There's only two variables here. And we are trying to do s equals solver. Did I solve all the previous problems? All except for 11. I have to go back and do 11. I might do that today if I have time. Yeah, I was busy on day 11. But yeah, I've done all the others. Solver. Oh, capital S, of course. Alright. So s.add, so I guess L is going to be greater or equal to 0. S.add m is going to be greater or equal to 0. We don't have any upper bounds. And now the core equalities are s.add, so it's going to be L times a vector dot I plus m times b vector dot I. So now that I write this out, I'm starting to sort of realize what I should have done. This is just simultaneous equations, isn't it? In 2 dimensions, there's enough for us to get let me just scribble something in Paint. Yeah, plus mu bi equals pi lambda aj plus mu bj equals pj. So that means you know what? Since we've started using Z3, let's just finish using it. Okay, so we do L times plus M times equals rise vector dot I. Then alright. For some reason I thought there were more dimensions than we really had. I think this is actually we could have just done basic mathematics to solve this. Alright, so then we're trying to minimize. How do you do that? We're not trying to solve, we're trying to minimize. Where's the minimize function? Minimize, add objective function to minimize, okay. S dot minimize. So it's going to be 3 times L plus M. I don't think we want a solver for this. Let's have a look. I think we want optimize. Okay.
stop check. Is that correct? Just try running this. So we're going to use this instead of what we wrote before. 0. Okay, fine. I don't think... I want to see what we get out of the check. It should say sat if it's satisfied. Unsat, sat. So unsat means it can't be satisfied. Sat means it can. So the ones where we get the model... No, I'm not using this correctly. S dot model L. Hang on. So we get the model. We want to extract the L value from it. No? Am I doing this right? I don't want to abandon using Z3 now because I've sort of committed to it. No, I want to find an example where they've used optimize because this is, I'm trying to use the solve methods and this is not. Opt.minimize that, correct. Opt.check, opt.lower. Oh, we're supposed to say h equals that. Alright, for whatever reason we're doing that. Okay, yeah, check. And then we want lower h, I don't know what that means. And then we want model. Stop model. Then what? Print desktop model. Aha! Result equals desktop model. Print result L result M. So we either get none or the correct integers. Okay. Hope this gives us the same result. It should. I mean, if it's found something. All right, min tokens, tokens. So we want to get tokens not equal to none, none. Oh, we can't do that with nuns. Whoops. Okay. If result return 3 times result plus there, else return none. And then we want tokens is not none. Should just be that then. Alright, why is it printing all this? Plus equal tokens equals get. Is this an int? Just print it. Where? Ugh. 3 times. I just want the number. What is going on here? Just give me the. How do I extract? This. Okay. All right. Hello, G12345. Yeah, I've been streaming Advent of Code every day. All right, we've almost got the answer here. All right, we don't want it as an expression. We want. Dot. I don't understand. Can we just cast it to an int? How do I get the int out of this? All right. Got. So that's the number. How do I get that number out of whatever that is? What is its type? Why are these the documentation so unclear? It just leaves it at that. How do I actually get the int out of it? We want. See your solutions in Captain's Discord, so it's nice to see you streaming too. Oh, okay, yeah. Yeah. I've done all the days except for 11. I was planning to do 11 today, but this problem is taking me a while, and I've sort of committed to using Z3, even though it's probably overkill, but we have the answer staring at us right in the face. How do I get these ints out? Print. How do you check the type of something in Python? Type. It's a class Z3 int numRef. Okay, that's nice. How do I get the int out of the int numRef? Int val. Like that? I think it's a none in this case. Hang on. Oh, God. None. Okay, what do we do when it's none? If result L is not none, or can I do this? No, it's not gonna be. It's not gonna be like that. It's gonna be. Yeah, we're gonna do L is not none. Oh, there we go. Okay, okay, okay. Return. What a mess. Return that plus that. Why doesn't it like this? Return that plus that. Okay. Else return none. Alright. Should be close to done. If tokens is not none, min tokens plus equals tokens. What is that? Print min tokens. What is this? No, I just want the int, not int val doesn't do what I think it does it? Val. Or maybe we want as long. As long. Okay. All right. 39996. Was that the correct answer? Yes, that was the correct answer for part one. All right. So now part two, it should hopefully work. So we have to say um um part 2. So this was part 1. So part 2, we want to add this huge number to both px and py. So px py equals this plus px, this plus py. And now we want to do this again. This is going to be 2, this is going to be 1. I don't know how long this is going to take to run. All right, let's try it. Done. Well, that was instant. All right, let's check. Correct. Z3. Kind of cheating, but it's a tool and it's useful for solving any kind of linear or integer programming problems. So I'm pretty sure if I had just gone down the mathematical route, I probably would have finished quicker. Z3 took forever to figure out, but it's actually good practice because we have had to use Z3 in the past for advent of code. There was one notorious problem which was about asteroids or asteroids in space or something. It was very difficult to do it without Z3. Some people did it without Z3, but it's not easy to code it up. So yeah, if anything looks like an integer program or a linear program, Z3 will work. I'm pretty sure now that I look at it though, I think I didn't really have to do that. I think this is only 2 dimensions, so it's actually this is probably high school stuff. I probably just need to substitute m for an equation involving L and then do something, but I can't be bothered to do that now. Z3 did it for us. I just solved it by hand. Yeah, I realize now that I don't know why I resorted to Z3. It's not as scary as it looks now that I split it up into the 2 components. I guess when I looked at A and B in my head, it was like an n-dimensional matrix, but it's actually just a vector of size 2. So yeah, you can actually just solve it by hand. This is kind of a dumb solution now. All right, well, anyway, that was good practice for Z3. I'm sure Z3 will come up again. I mean, it won't be needed, but there's probably problems where I'd rather do it in Z3 than try to remember my linear algebra. Took me a while to understand there was really just one solution for every machine. Yeah, because it's yeah, that's kind of what I realized eventually when I was halfway into the Z3 thing. There is just one solution because you can solve the set of simultaneous equations, yeah. This is full like Gaussian elimination in 2 dimensions, so it's just easy to solve. You don't have to find the inverse of a matrix or anything. Uh, yep. So I'm just wondering if I should go and do problem 11 right now. It would be nice not to just leave it hanging, so yeah, I should just have a quick look at the stats. 13. Ooh, well. Seems it was a difficult one for some people. I don't know. I guess this problem was easy to get intimidated by, and that's why I resorted to Z3. It's a bit hasty. It's maths, so it's automatically hard. I suppose maths wouldn't be very fun if it was easy. All right, I guess I will actually go and do 10, 11. Which one is it? 11. Okay. I just need to take like a 1 minute break though, so I'll just switch to the stream starting screen. Also, I need to change all the stuff. All right, we're going to change. All right, I'll just switch to the screen for now. See you in 1 minute.